Welcome back to another video by the helpers, and today we're going to discuss the topic of physics, the vernier scale and the macrometer screw gauge. So let's jump into it. The vernier scale, as you can see the diagram over here, I've divided it into two basic parts in order to make things clearer. First is this is the main prongs, or you can call them the jaws. You put any object over here and then you can for example, put an object over here and you can tighten this. Okay, this whole thing can slide over here. Okay, and when you tighten this, you will be able to read the measurement of the object that you placed over here. The other main function of the vernier scale is it can find out the diameters, and that is part 2. Okay, so how you put any, for example, I take a bottle cap. You put a bottle cap over here. Okay, and then this is also slidable in this direction. Okay, or you can tighten it up. When you pull it, these prongs will come over here, and therefore the cap will fit snugly on top, and so you can read the diameter of this cap and any other object that you want to measure. Okay, now the important part is the vernier scale has a least count of 0.01 centimeters or 0.1 millimeters. Okay, remember that. We'll do a few questions to make things clearer. Let's go on. The macrometer screw gauge. Now this is another device in order to measure things. Usually it's used for measuring more accurate stuff. For example, a wire, a thin piece of wire, right? So if you put a wire over here, this thing will rotate and you can tighten it, and therefore you can measure the readings, right? This small stub is called the anvil. This place is the frame, and that's the lock. Okay, then there's a thimble, and the readings are over here. They're a bit unclear in this picture, but the readings are present in this place. Okay, then as I've said, this is the sleeve and this is the ratchet knob. Okay, now this is not that important, so I'll skip it. However, the basic is done. If you want to take a screenshot of this, go ahead. I'm not going to discuss it as I've already explained the basic structure. Now let's do some questions. The screw gauge. Okay, so now the basic structure is very like the vernier scale. Now there are two big lines and two small lines over here. The small lines represent 0.5. Okay, so in this case, if this is 2, this will be 2.5. This will be 3, and this will be 3.5. Okay, so firstly we will write 3.5. Actually it should be, yes, 3.5. okay, secondly we will look at this scale. Okay, this curve, we will see the line that matches exactly with the straight line over here, right? So we'll have to match the lines on this side and on this side. Okay, so this is 20, this is 21, this is 22, right? So the line over here is 22, and therefore we'll write 0.22. Okay, so in the first scale we found was 3.5. The second scale we found was 0.22. When we add this up, we will get the answer. Okay, which should be 3.72. Okay, 3.72. That's correct. And let's proceed to the second one. This one. Okay, 3.5. This is 4. This is 4.5. Okay, 4.5. Now we've already found out this is 4.5, so the main scale is 4.5. Wait, the basic structure is, the basic thing you need to remember for this is, the least count is 0.001. It's wrong. 0.001 centimeters or 0.01 millimeters, right? Usually we have to write the answers in millimeters. The answer for this one was also written in millimeters. Okay, so this one, 4.5, as I've discussed, is the main scale reading, and then we have to find the other scale reading. Okay, This is 10, this is 9, this is 8, 7 and 6. Okay, the line that's meeting exactly from here and here is 8. Okay, as we can see 8. Therefore the answer should be 0.08, because the least count is 0.01, so this scale should be 0.08. Okay, so we'll add this up. 4.5 plus 0.08 is actually 4.58. The answer is written over here. Okay, now let's proceed. 4.5, this is 5, 5.5, and this is 6. Okay, so the first scale reading is 6.0. Okay, then we'll proceed to the secondary scale reading, which should be 15, this should be 16, and therefore this should be 17, right? So 0.17, because there's 2 decimals over here, so 0.17. 0.17. Simply add this up, you'll get 6.17. This is a clearer working. Done. Answer is correct. The last question. 6, 6.5, 7, 7.5, and this should be the 8th addition. Okay, therefore the main scale reading is 8.0. The secondary scale reading is 25, this should be 24, this should be 23, and so on, right? So the line that meets over here and here is line number 23, right? So we will write 0.23, 0. Oh, sorry, I shouldn't write it over here. Confusion. Okay, 8 and 0.23. Okay, so therefore if you add them up, you'll easily get 8.23, and that is your answer, right? 8.23 meters. That's correct again. Okay, now there are different scenarios in which a macrometer screw gauge can be shown in your exam papers. This is another method, and I'll try to explain this as well. Okay, as I previously shown, we have to first find the main scale reading, which is this scale reading. 0, 5, 10, 15, 16, 16.5, and therefore this should be 17, right? We have to find the reading that is just before this scale. Okay, this line, which should be, we can see this line over here, right? We can see this line over here, right? The 15, 16, 17, right? So the answer over here should be 17. Main scale reading is 17.00. The secondary scale is, I marked it with blue, 30, 31, 32, and 33. We write 0.33, and therefore the answer will be 17.33. I hope that's clear. We'll proceed to the next question. Okay, so this is 0, 0, then there's 0.1, 0.2, 0.3, and 0.4. Okay, this line 0.4. Okay, right before the macrometer measurement line. Okay, so this should be 0.1234, 0.4, and the secondary scale reading should be 20, 21, 22, 23, 24. Okay, actually should be, yes, 24. 24. Therefore I'll write 0.24. Simply you just have to add it up, and the answer will be 0.456 and 4, right? Now the basic thing you have to remember is the least count, which for vernier scale, as I mentioned, is 0.01 centimeters and 0.1 millimeters, and for the macrometer screw gauge it is 0.001 centimeters or 0.01 millimeters. Okay, I hope that's clear, and we proceed further. Okay, so this is another type of the vernier scale. We did this type of scale first, and now this is just another form. However, the basic idea is simple. Okay, First you have to find the value that is right before the vernier scale, which is 2 in this case, right? So we'll write 2.00. Usually in vernier scales we have to give the answer in centimeters, and therefore I've written it to 2 decimal places, centimeters, okay? 2.00 centimeters. And then we'll have to find the vernier scale. Which line is matched? We'll count 1, not this, we can say this line, okay, is matched completely, and therefore it will be 1, 2, 3, 4, 5, 6, 7, okay? This should be the 7 division, as we can call it. Therefore the answer should be 0.07, and therefore the answer should be 2.07 centimeters.